open digital education is important, period.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. Today we're talking all about online learning with a pioneer in the field who just happens to be an engineer himself. During our Industry Tech Days this past September, I got to speak with Anant Agarwal, founder and CEO of edX, about the present and future of online learning. For engineers, online learning has been an opportunity to grow at your own pace, but edX is taking things one step further, offering you certificates, micromasters, and even master's degrees in your chosen area of focus. Listen to this.
Hello, everyone, and welcome to Day 2 of Industry Tech Days presented by All About Circuits. I'm Dave Finch, host of Moore's Lobby, the podcast by engineers for engineers, and today is Tuesday, the 1st of September. And let me ask you this. Did you catch Microchip yesterday talking about gate drivers for silicon carbide devices? Or how about Vigilant talking about portable instrumentation when so many of us are work from home nowadays? This Industry Tech Days event is awesome, and we're only one day into it. Today, for example, we've got NXP, ST, Mentor, a host of other industry leaders, and you can be here with us live or catch it all on demand, whatever suits your schedule. We're just glad you're taking advantage, frankly, of all this great content and hopefully getting to know some new friends in the industry. Our keynote speaker this morning is Anant Agarwal, founder and CEO of edX and an MIT professor of electrical engineering for more than 30 years. So, Anant, thank you for joining us on this second day of learning and professional development.
Thank you, Dave. It's a real pleasure for me to join and chat with you about a subject really near and dear to my own heart.
Mine too, and I've been really looking forward to this session. And, we're all here in the spirit of growth and improvement, right? So I think my first question is probably the broadest one, and that is, from your perspective, both as an educator and as an engineer, why is open digital education so important right now?
What's interesting is that open digital education is important, period. It's always been important. However, during these crazy times with COVID-19, open digital education, online education, remote learning has become incredibly important again. The reason I say that is, let me provide a bit of a quick background on edX. So I'm the founder and CEO of edX. edX.org is a nonprofit, and we are a learning platform. And we were founded by Harvard and MIT, and we partner with some of the top institutions in the world, like MIT, Harvard, Berkeley, Stanford, Cambridge, Oxford, and others, companies like Amazon Web Services, IBM, Microsoft, and others who offer content on edX, all online. And then in our platform, we have learners from all over the world and companies from all over the world that take our courses. So we have more than 3,000 courses on our platform, and we have more than 33 million unique learners from every single country in the world.
Wow.
And we have over 1,000 companies whose employees are taking our courses. And these 33 million learners have signed up and taken more than 100 million course enrollments through the years. So online learning was important to begin with. But what has happened during this time, during COVID, take the month of April, for instance, we enroll more learners in 1 month than in the entire 2019 year.
Really?
The enrollments on edX went up by a factor of 10 during the month of April. So we enrolled 5 million new learners, new unique learners from all over the world in 1 month, which was what we would have done all through the year of 2019. So online learning is becoming incredibly important as people are hunkered down, learning remotely, working remotely, and looking to upskill and learn something new during these times.
Absolutely. And where, first of all, that's impressive and exciting news that in 1 month time, you can double the prior year's, total enrollments. And where do you see engineers going for online learning? What are the I guess what is the behavior of engineers like me going out and trying to access this sort of content?
Engineering is a very, very fast growing discipline where things change almost on a daily basis. Data science, for example, the phrase wasn't even coined in 2008. And so the new areas where machine learning, IoT, tiny machine learning, all new things that are coming out at the intersection of hardware and software and circuits. And so engineers need to go and learn new things all the time to keep up to speed with technology. And if you are an engineer, you have a family, you're working, or you're looking for a job, what are the odds that you're going to be able to go back to a university for 1 year or 2 years, spend $40,000, $50,000, get a master's or another bachelor's? No way on earth. So instead, you are going to use remote learning, online learning, and you can go to sites like edX.org, where you can come in and you can learn everything from the fundamentals of circuits. I teach 3 courses on edX. These are the foundational courses that I also teach at MIT in circuits and electronics. And you can learn for free. However, if you want a certificate, you want the exams and graded assignments, you pay a small fee on the order of $100, $150 in order to get the certificate and the assignments. And so these are places that you can come in and upskill from foundational engineering skills to more advanced skills. We just launched a course from Harvard and Google engineers on tiny machine learning. That is one of the hottest areas at the intersection of circuits, hardware, and the software. Just imagine new courses of the sort that you can come in and upskill. And so online learning is the way to go in order to come up to speed and reskill in these areas.
Absolutely. I say this probably far too often, but the mistake that a lot of people make, the false assumption, is that every engineer is, of course, an expert on every area of the circuit board, and that isn't the case at all. And so when you have, kind of these explosions of technology enablers coming along, well, if you are a motor control designer or a power supply designer, and somebody starts talking to you about RF or connectivity, as you said, or even, tiny ML, where do I even start with that? What microcontrollers would even accommodate this? Having this sort of micro-focused education opportunity is really great, because the way I see it, even if you could convince your company to send you back to university for a year or two, and you could somehow figure out financially how to make that work, support your family in the meantime.
Do you want to do it? I mean, it's not even clear you want to do it, right?
But that's a good point. And you're also learning at a sort of pre-scripted pace that has to accommodate the fact you've got 30, 100, 200 other people in your course. Whereas with an online course, well, I can learn at my own pace. And if I need supplemental information, I can absolutely find it somewhere.
Absolutely, Dave. I think you've hit up on a very important point. For upskilling, and particularly in engineering, it's not just about spending the 1 year in college or the money. The problem is that you know a lot already. You've been learning on the job. And you go back to get the 1 or 2 year additional degree, 60% of what you learn, 70% of what you learn is old stuff, but you have to do it again in order to get the degree. Instead, what we are doing on edX is modularizing education. Now, much like in circuits, you build a big system by creating modules and plugging the modules together. You take an op-amp, you take resistors, you take the components that you need, and you plug them together as you need them to build bigger circuits. So modularity is key and stackability is key. So what we've done is we brought these circuits concepts to education and created Lego blocks of education where instead of having a master's degree or a bachelor's degree, we've now launched micro masters at the graduate level and micro bachelors at the undergraduate level, where you can take modules of learning. So for example, we have a micro masters in nanotechnology from Purdue. And so you can take these modules of learning and earn a micro master's. It's about 20% of a master's degree in electrical engineering. And for about $1,000 or so, per course, you can actually take these courses and get the micro masters from Purdue in nanoscience. And you can do it completely online. There's no admissions. You don't have to apply, no GRE, no nothing. You just come in with one click, you're learning. And then what you can do is you can stack these up. Purdue has also launched a master's degree in electrical engineering on edX, completely online. And so there, the whole master's degree is about $20,000. You can take the micro masters and you can just stop there and put that on your resume or LinkedIn profile and upskill in nanotechnology. Or you can say, you know what, I love this stuff. I want to get more of these Legos and stack up more of these Legos and get a full degree. Then you apply for admissions to Purdue and you can continue to learn online on edX, and you get a master's degree in electrical engineering for about $20,000 and completely online. And so this modular stackable approach gives you the flexibility. And really, this is the future of learning where we're applying those very circuits and electronics concepts of stackability and pluggability and building bigger components from smaller components to education. And so we're loving it and people are loving it.
This is the danger of me hosting these keynote sessions, because every time I have a conversation with somebody like you, I want to immediately divert and go off into a new career path. Like, I want to get involved in this right now. Hey everybody, it's Dave. In 2020, DigiKey Electronics and All About Circuits kick off their second annual University Ambassador Program, a yearly program that helps engage electrical engineering leaders at universities all over the world. DigiKey's 25 ambassadors help engineering students by outreaching to their communities, distributing swag to their peers, and attending local meetups. Through the Ambassador Program, DigiKey aims to foster innovation and strengthen a sense of community for next-generation engineers. To attend events, or if you're interested in becoming an ambassador on your campus, please visit allaboutscircuits.com/DigiKey-ambassadors. That's allaboutscircuits.com/digi-key-ambassadors. So another interesting parallel to engineering that is coming to mind as you're speaking, and I can hear the engineering voice ringing out loud, and I can also hear the educator in you ringing very true. And that parallel is, exactly what you're solving for. So by offering these modular, stackable, and even micro masters, micro advanced degrees in very specific topics, you're not solving for problems that aren't right in front of you at the moment. You're solving for X, right? And that's another big difference compared to, say, a university experience where they say, well, if you want to get a degree in electrical engineering, you also need to have a few credits in psychology, and it's like, wait a minute, what? Are there other ways that you think sort of continuing professional education differs from, say, a traditional undergrad or even a traditional, graduate development process?
Absolutely, yeah. And Dave, you said it yourself, which is, when you go to a university and sign up for a 1-year, 2-year master's degree, or a 4-year or 5-year or 6-year years that people usually take for an undergraduate degree, you are largely given a menu of what the university believes you should know.
Right.
take courses and content. There's a lot of foundational courses, and we won't get into the argument of whether the foundational courses are useful or not. They are. You develop very helpful soft skills and writing skills and so on. But when you're an adult, you want your time to be spent learning relevant stuff. It's the R word, relevancy. I know what I want. Give me what I want. I mean, can you imagine going to a restaurant, okay, and it's a fixed price, fixed time menu. You have to sit down there for 3 hours, and you have to go through all of these courses. You don't like fish? Tough luck, buddy. You have to eat the shellfish. You don't like your vitamins. You don't like kale. Right. Sorry, you got to drink this, glass of kale juice. And this is that's our education system today. It's insane. Yeah. But for adults in particular, and by the way, frankly, it's for everybody. But for adults in particular, we know what we want. You know what you want, and you want to go and learn about. Hey, I want to learn about nanotechnology. Okay, I want to learn about semiconductors. I want to go and learn about MOSFETs. I know what I want to learn about. Maybe I want to learn about what is IoT stuff. I want to learn about IoT. I'm an electronic and circuits engineer. I want to learn about data science and linear systems and how statistics applies to big data and so on. I know what I want. I need to go learn it. And it's important for my job, and I go and apply it. I want to do that quickly. And particularly in these COVID times, as we've interviewed a lot of our learners, 26% of them are telling us that they are seeking these micro-credentials in pandemic-proof areas. They're very specific areas they want to upskill in that are pandemic-proof, that will make sure that they're resilient to all the stuff that is hitting the world today. And so micro-credentials are critical. I want to go and earn a micro-bachelor's in this specific topic. I want to earn a micro-master's in big data or in AI or in nanotechnology. And the relevancy becomes very important for you. You don't have the time and patience to spend 1 year, $40,000. Instead, you're willing to spend $1,000 or $1,500 and spend 3 months. And at the end of it, I know I need to get a micromaster's. Very specific. You want to be doing very targeted things quickly.
Exactly. And are employers now starting to see the value in these sorts of MicroMasters programs? I'm thinking back to, before this model, which you are excelling at, there was the traditional, well, you could either go to university and slog away every night going to campus, doing, getting your master's degree over the course of, say, 2.5 years. Or you could go to something like a University of Phoenix online, or you could do but it's still the same model. It's a master's degree. It's just, instead of being in a physical classroom, you're online. And I know that from my own experience, there were people that I worked with who said, I'm going the online degree route. I'm going to go with University of Phoenix online. And the internal bias at the company that I was working at was that, like, well, you can do that. We'd rather see you go to, like you said, Purdue or Georgia Tech or Iowa State or, some really strong engineering school and be there in person. But what you're talking about is quite different. What you're talking about is being able to put on my resume, I am, say, certified from edX in this particular, power management series. Is that the model?
Yes, I think two things have changed. Previously, you talked about getting a previous online degree from some for-profit school whose reputation has been questioned over the years. And yes, that's all. That's the only option you had, 10, 20 years ago. Yeah. Things have changed in two distinct ways. One is top engineering institutions are now offering credentials and full degrees on edX. So I talked about Purdue offering degrees in electrical engineering, degrees in mechanical engineering, and last month they launched a degree in civil engineering on edX. 1 year completely online, around $20,000. Georgia Tech has cybersecurity and analytics degrees on edX. UT Austin has degrees in computer science, data science for $10,000. The campus degree in data science and computer science is about $40,000, $44,000. The same degree, the same credential is available online on edX now for $10,000. And it scales. On campus, they admit 30 students or 40 students. Online, in our Georgia Tech analytics degree, we have more than 3,000 students going through the analytics degree for about $10,000 on edX. So the one thing that has changed is that top tier schools, top 10 schools like UT Austin, Georgia Tech, Purdue, and others are now offering these degrees on edX very affordably. A BU has a $24,000 MBA on edX, and you get the same MBA as if you went to campus. So that's one thing that has changed. The second is that for those that don't want the whole degree, you can get the micro credential. You can get a micro master's in analytics from Georgia Tech. And then if that's all you want, you get the micro master's for about $2,000 completely online with open admissions. And you put that in your resume, you learn just that piece. But then you decide you want to go get a full degree. You can stack up these credits and then go for the full degree, but you can make that decision later. So two big things have changed in summary. One is that top engineering brands are now offering these degrees on edX at very affordable prices. And second, you can also earn micro credentials if that is all you want. So you can do very targeted learning. You don't need to go and buy one size fits all for everything that you need.
If I were operating a traditional educational institution, something like this opens up my field of available candidates tremendously. And so if, for instance, we know that we have the infrastructure, the dorms, the parking, and the number of classrooms to accommodate this many students. So we're going to be pretty selective, and that's fine. Why not be able to open that up? And this is bringing up another point. Talk to me a little bit about improving access to educational resources and kind of what this means for all of us, not just people who are currently in a job and want to do this other thing in their job, but even for people, it's a big, huge industry, even for engineers who might say, you know what, I do want to get more into the business development side or something like that.
Absolutely. I think online learning, MOOCs, individual courses, these programs where you can start learning for free are dramatically increasing access to all kinds of education to all people in many different ways. One is that we have 33 million learners on edX. When I launched my circuits course on edX, the first course on edX in 2012, we had 155,000 students enroll in a MIT hard electronic circuits course from 162 countries.
Wow.
And at the end of the day, about 7,200 students passed an MIT hard course, and they earned a certificate from MIT in circuits. So when people complete these micro-credentials, these come from the university. They get a Purdue master's degree. They get a Georgia Tech micro-masters in analytics. And in Georgia Tech, Purdue, and UC Austin's cases, it's the same degree that they get on campus. So access is dramatically increased. For micromasters, microbachelors, and courses on edX, there's no admissions. So with one click, you're in and you can start learning for free. And we have millions of learners, like in my circuits course, 155,000 in the first course. And it's been offered multiple times. And today, over 600,000 students have taken circuits and electronics that is offered to MIT students. So it dramatically increases access.
Absolutely.
And the second is that many learners want not just to learn about circuits or nanotechnology or mechanical engineering. The world is getting more hybridized. Employers are looking for hybrid skills. Employers are beginning to recognize this. They've begun to recognize micro-credentials. It's not just degrees, but they've begun to accept micro-credentials, and more employers have begun to do that. And what they're saying is that we need hybrid skills. And so if you are an engineer, for example, it's also very important that you learn writing, soft skills. We have a professional certificate program from Rochester Institute of Technology in soft skills, where you learn critical thinking, negotiation, storytelling, writing, business presentations, teamwork. And those are critical skills that employers are looking for. it's not just about engineering education, but you also have to augment it with certifications in the soft skills. And for engineers, that combination is particularly important. And employers are looking for that. And online, you can go on edX, for example, you can come in and do these certificates in various areas. You go get a master's degree on campus, for example, it's very stovepipe and very focused on one set of topics. You are not going to be able to pick and choose. Let's say you want to learn about product management. You can't do that. You want to get a small MBA along with a degree. You cannot do that. But on edX, you can earn a MicroMasters in Business Administration from University of Maryland. And so you can earn these smaller credentials, and you can sort of synthesize the kind of engineer, the kind of business leader, the kind of product manager that you want to be in the future.
Absolutely. And that's this hybrid skills is so massively important. I've been a hiring manager, and I will tell you that we all put the education on our resume because somebody else told us we have to do that, and so we all just say okay and we do it. But and then even in the job descriptions on the job postings online, people say minimum 4+ years, and then you need your BSEE and blah blah blah. Well, I will say I've never once looked at a resume and said, oh my gosh, they went to state college, hire this person immediately. What I'm looking at is, what have you done, and are you right for this role?
Yeah, exactly. I think that's very important. More and more employers are looking for the skills. And previously, how do you show that you have, let's say you have a bachelor's or some degree in mechanical engineering? Okay, how do you show on your resume that you've learned mechatronics, that you've learned nanotechnology, that you've learned data science or machine learning or soft skills? How do you show any of the stuff? Well, the beauty is that you can earn these micro credentials and you can put them on your resume. You can put a certificate from RIT, a professional certificate from RIT in soft skills. You can put a MicroMasters from Georgia Tech in analytics, a top 10 school, on your resume. And so now without too much extra, without spending a year or two on it, in a few months you can earn these credentials and put those on your resume. And in fact, the data bears it out. In surveys of learners on edX who've earned MicroMasters credential, so we do surveys after 3 months after they're earning a credential, and 90% of these MicroMasters earners on edX are telling us that they had a career advancement because of that credential.
Wow.
Either a pay raise, a promotion, or a new job. And so employers are recognizing this, and people are being rewarded for it.
That's tremendous data, and they're being rewarded for that. And what people don't realize is, again, getting back to the sort of hard skill, soft skills, you also get rewarded either directly or indirectly for those soft skills. And so where somebody might look at it and say, well, if you're just going after a micro degree, a MicroMasters, or even just a certification in, say, the thermal characteristics of maybe semiconductor physics, we'll say, well, I would challenge that, because it's not limited, because you go for that certification, but you also then can pick and choose. In my career, I'm definitely going to need to understand, like you said, whether it's product management or something like that. These are all available from edX as well. So you can procure your own well-rounded education without being handed a one-size-fits-all education.
I think that's becoming very important. I think the one-size-fits-all, again, let me not knock that too much. I am a professor at MIT, as you said, for 32 years, and I believe in that. It's good stuff. But today's market is different. Today's market is valuing these hybrid skills. I'll give you an example from my own life. A relative of mine has a degree in a bachelor's in mechanical engineering. They have a few years of experience, and they were interviewing for a job. And there were two kinds of questions they were asked. One is about mechanical engineering, fluid dynamics and control theory and all the usual stuff.
Yeah.
Also asked about, hey, have you, they wanted to learn about, have you had any experience? Do you know any project management? Have you led teams? How do you pull a project together? And so more and more we're seeing, particularly for people who are 1, 2, 3, 4, 5, 10 years into their careers, and they move into managerial positions and they lead teams, many of these skills like project management become very useful. And how do you signal that you're good at it? How do you signal to your management that you need to be promoted to become a manager? Well, you could go and earn a micro-credential in project management. Some of the amazing skills today are Scrum, Agile. These are 21st century skills. And you could earn a micro-masters in project management on edX from RIT. You can earn a professional certificate in things like Agile, Scrum. You don't learn these at universities. At universities, these are very cutting edge, very modern techniques that show you how to build product and lead teams in a very agile way. And I've talked to any number of employers that say, hey, look, I want to find out, has this person had any experience in the previous work in Agile or Lean or Six Sigma or many of these workflows? And you can learn all of these things and put a certificate on your resume. You put a master's degree in computer science or mechanical engineering or EE, it's difficult to show that, but you earn these micro-credentials, you can get them in Scrum and get them in specific things that you can highlight for future employers or your own employer.
Definitely. That makes perfect sense to me. And, it does beg the question, how can we handle educational situations that maybe traditionally have been hands-on, like working in the lab, for instance, and you physically need to see the results of what happens in avalanche mode or something like that?
It's a great question, Dave. And I want to start by saying that today's online learning is not our grandfather's online learning. Online learning from the 90s and from some of the for-profit institutions that you were used to 10, 20 years ago, long videos and multiple choice questions. That is so 1900s.
Right.
Today's online learning is so different. On edX, for example, I mentioned I teach a sequence of circuits courses. And what use is a circuits course if you don't know how to build a circuit? And so we use simulation technology and Google circuits and edX, go to edX and search the circuits course and check it out. We have an online circuits lab. It's a gamified version. You see a breadboard, and on the right-hand column, there are a bunch of components, transistors, resistors, capacitors, inductors. And then you also have a set of instruments like oscilloscopes and spectrum analyzers and frequency analyzers, signal sources like music sources and sinusoid sources. And then what you can do is you can, using drag and drop on this virtual breadboard, online on edX, you can build these circuits. And then with one click, it simulates and it runs, and you can see the waveforms. If you provide a music input, you can see what it looks like at the output. You can play a lot of these hands-on exercises and games, if you will, where we are turning labs and maker stuff into virtualized, gamified experiences. And frankly, this is what work looks like. At work, most of circuit design today is virtual and online. You're using CAD tools to do it, and we have that online for many of our courses. So you really have to go experience it to believe it, and it's just a lot of fun to do it.
Yeah, that's I can see so many different applications. And the other thing that it enables you to do, speaking of learning kind of at your pace, is that I remember in a few of my electronics labs in college, there would be a grad assistant who would maybe be making a lot of assumptions that everybody understood how to dial in the functionality of an oscilloscope to make sure that what you're capturing is really what you're seeing, is really what's happening in the circuit, and or how to mitigate noise. And these things are kind of glossed over sometimes, depending on who your grad assistant is or your professor is. But you can predict for this, you can design for it with an online educational model in this virtualized environment, where if you start to fiddle with the knobs, so to speak, of a scope on the front end, it can pop up and say, are you sure you need to be adjusting this? Learn more about you've basically got a coach that sits right next to you the whole way through if the course is kind of constructed that way.
Absolutely. And it's it gamifies learning where with the online lab, you don't have to wait till midnight to find a spot in a lab. You can play with it as
Sure.
as often as I remember in various labs that I've been to, labs have a capacity of 10 or 20 people. They have 10 or 20 scopes, and kind of that's it. And then people have to wait in line and sign up, and you're chased out in an hour, and
Sure.
and it's a mess. And what do you do? But now, if it's online, you can spend as much or as little time as you want. You can do all kinds of what if sorts of experiments and design experiments. I urge you to go check it out. Check out the breadboard in the circuits course on edX, and you can play around with it, and it's a lot of fun. And you can do it at any time of day or night. It's all based on simulation, and the beauty of that is you can play with all kinds of components. You don't have components running out on you. You can adjust components to any value that you want. You can set up any kind of source. You can look at and see what waveforms look like almost instantaneously. And you don't have to. And if you're in a poorer school, for example, since this is all online, you don't need expensive oscilloscopes and other devices costing tens, hundreds of thousands of dollars, to learn.
Exactly. I know that this is a not-for-profit endeavor, which I admire tremendously, by the way. We need more just lifting people up for the sake of lifting people up, and not trying to monetize every last thing that in our day. But if I'm looking at this cynically, as somebody who could see the education model and then can also see a business model behind it, let's say I've got Dave University. Dave University does not, like you said, have to spend all this money on investing in infrastructure, lab equipment, desks, all the stuff that you need, a beautiful quad. I can say, I will facilitate these different certifications, these different degrees, entire degrees, and my overhead is minimal. And the money that the students are saving, by the way, on their education can certainly buy a benchtop power supply and a scope.
That's absolutely right. I think online learning and the modularization of it, as we've discussed so far, really presages a new era of learning, even at universities. And particularly after COVID-19, learning is not going to be the same ever again. I presage a future where learning is going to be blended. And we've done some experiments of sorts. So, for example, in 2012, we worked with San Jose State University to do exactly what you said. They offered the circuits course from MIT that is taught on edX to the campus students. And they offered it 3 semesters in a row, fall of 12, spring of 13, fall of 13. And Khosrow Gadiri was the professor. And what they did was they flipped the classroom. There were no lectures. Instead, students watched the videos, did the exercises and homeworks on the edX platform. And what he would do with the students is get them to work in groups and solve problems together. And his role as an instructor was more a guide on the side as opposed to sage on the stage. And he would help them with the work. And they would be learning at their own pace as opposed to trying to follow along at a fast-paced lecture. Here, you can pause and rewind as many times as you want. And this blended model was widely successful. So he's published a paper in one of the electrical engineering journals. And the paper showed that the traditional pass rate for that introductory circuits course at San Jose State University was about 59%. So the failure rate was over 40%.
Right.
With this online blended learning model using the edX MIT course, the pass rate went up to 91%. From 59 to 91%. So not only is it more engaging for students, but the outcomes are better as well. It's also more efficient. Why do you have to hand grade a whole bunch of problem sets? They did the virtual labs. All of the things where homeworks were graded automatically by computer. And you can type in equations. We have equation graders. It's not just multiple choice. It's very, very different. We have drag and drop exercises. We have labs. All of these can be graded completely online. And the results speak for themselves. That result at San Jose State was 59% pass rate going up to 91% in the blended model of learning. So I see a future where more and more universities will begin to share. So today, if I'm a university, I do everything myself. If you're Dave University, you do everything yourself today. Mm-hmm. But in the future, I see a lot more sharing and componentization. It's like circuits, right? If I'm Intel, how many of the, or if I'm, pick your favorite circuits company, if I'm Qualcomm building circuits, or if I'm Cisco building circuits, or Arista Networks building systems of circuits, none of them build all their own components. Intel does not build all of its own components. They build some things themselves. They might buy some linear components from analog devices. They might buy some other components from, Qualcomm and so on. So you buy and share, and you create an ecosystem. Universities are not like that. I see a future where universities, through online learning, will begin to share courses. Where if you're Dave University, you'll say, you know what, I'm going to get the circuits course from MIT through edX. And you, in turn, let's say you're an expert in, SPICE simulations and modeling of semiconductors. You offer that course on edX, and maybe another university takes that course. So people begin to share. And to facilitate that model, edX launched about 2 months ago. We launched edX Online Campus. edX Online Campus is a way for universities to come to edX and sign up all their students to start taking courses from their own professors or from professors at other universities. And so we believe that edX Online Campus is a way for universities to have a platform where they can begin sharing content across other universities.
So it's already in process. And by the way, I would that's very interesting. I wasn't even aware of this part of it, but that's I'm glad you bring that up, because it also speaks to, when you say you envision this future, it's one thing to have kind of a pie in the sky idea of what you want things to look like, but what you're doing at edX is really important, because you're actually it's down to earth and happening. And we're also seeing this happening in other kind of pockets throughout the industry as well. For example, EE Tech Media is the company that owns All About Circuits, right? And traditionally, electronics media was very much, the model was the sage on the stage. And I love that phrase. It was, we are going to preach sort of from the technology pulpit, and this is what we say you need to know. And then they kind of shove it down your throat. And that's great if they're shoving the things down your throat that you need. But that's not a 100% success rate. Your model being hybrid with guide on the side is what we're seeing with things like All About Circuits, the website. And the reason I mention this is because obviously we've got so many of those community members watching right now. That's part of the appeal to me as an engineer of brands like this, because you've got other experts who are sort of there with you, lending guidance and not preaching from the pulpit.
Absolutely, Dave. I think you can also be very nimble and fast. So, for example, we heard more and more companies come to us saying, hey, look, we need to train our employees on how to lead remote teams. Okay, more and more people are working remotely. How do we do that? But you can't go to a university and take that course. And so we partnered with a couple of colleagues who've taught at the Graduate School of Business at Stanford in the past. And they launched a course called Humor X, where it's a course about leading remote teams and using humor to do that. And so we just launched that course. And so you can launch very, very cutting edge topical courses from world experts in that topic in a matter of days or weeks. We launched a course on how to use ventilators from Harvard and Mass General Hospital. It's a 1-week course, and we launched that about in April to meet the demand for people who had to learn to use ventilators during our current COVID outbreak. And already We have over 300,000 people from all over the world taking that course. And so you can be very topical and launch new cutting edge courses within days or weeks. And the odds that you're going to be able to get the same experience by university, you 6 months to apply, and you get selected, then you go, you travel somewhere. It's 1 year before you even sneeze.
Yeah, I love that expression too. I'm going to steal all of these expressions. That's brilliant. This is, what we need. I think the world also needs how to listen to a different opinion without shutting down and calling the other person, saying they don't know what they're talking about. There are so many soft skills type courses like this, like you said, whether it's how to do, lead an online team, or even just navigating difficult work conversations. That's something, nobody's born knowing how to do that. And so I could keep going, and I've only got like 35 more questions that came up from this. I should honor the fact that we do have an audience, and I want to make sure that we have time to capture some of those questions as well. So we've been getting a scroll in here, and I think we have time for a few. So if you're watching this live, use your chat widget over there to send us your questions, and we'll try to get those answered as quickly as we can. But let's start with the ones we have right in front of us. And this one is coming from Sunil, also from La Jolla. We've got some strong representation from La Jolla. Sunil is also talking about the soft skills. So he's can you please explain can you please explain the importance of soft skills for, it looks like, I'm trying to decipher the question, but it looks like soft skills for practicing professionals who have already been in the industry, and versus the skills that a young engineer, maybe somebody in college or just graduating, is hoping to acquire, and kind of what those differences are from your perspective. And Sunil, if I'm not interpreting the question correctly, I apologize.
No, it's a great question from Sunil. If you're a practicing engineer and you've been working for some time, I've often heard engineers tell me, "Hey, look, I was looked over for promotion, and they promoted so and so, but I'm technically so much better from that person." And it turns out that promotions often come because of soft skills. And for people who've been working in the field, some very important skills are leadership skills. Leadership skills have to do with how do you state what matters, how do you listen to people, how do you lead teams, how do you build consensus. You talked about active listening. These are all part of leadership skills. That's very important. A second example is negotiation skills, where you have to work with other managers and negotiate for resources or prices and other things. Project management is very important. Management is very important. And management is multiple things. In management, you need to learn a bit about marketing, about finance, about organizational behavior, accounting, strategy. And these are all examples of what you need. These are soft skills for managers. Project management is about how do you lead a project? How do you decide timelines? How do you make sure your supply chains are in order? So these are all soft skills that are very important for people that have been working for some time, and you can learn all of these. And you just as an example, you go to the search bar on edX and you type in any of these, and you'll see professional certificates or courses in virtually all of these. Now, for a starting professional, all of these skills are still important, but what's even more important is communication skills, teamwork. How do you present? How do you communicate? How do you write emails? And these are all also very much skills that you can learn.
Yeah, I would second that. These are the things that advanced me in my career. There have been so far, and these are the reasons why I have lifted other people up into sort of leadership roles, is because I saw. I assumed that the hard skills were table stakes, and it was who they were as a person and a contributor around those skills that really seemed to sell it for me. All right, we've got Anna from Krakow, and can you explain the So can you explain the requirements for acceptance or enrollment in a course?
So that's the beauty of it. That's a 4-letter answer, none, NONE. So you can come in, and with one click, you can enroll in any course, and you can start learning for free. The click. It's really, the requirements are, it's a mouse, and you're enrolled in a course and you start learning for free. There's no admissions. For MicroMasters, which are modular programs at the master's level, for micro bachelors, which are 2 or 3 courses bundled together at the undergraduate level, and these are credit backed. Again, no admissions process. You just click and enroll, and you start learning. Professional certificates and courses, same thing. You just start learning. And then if you want to, after you finish that, if you want to get a master's degree, then you can apply to the university for the master's degree. For example, the electrical engineering masters from Purdue on edX. And even there, the universities will take into consideration your performance in the MicroMasters, and it will help you get admission into a master's degree as well.
Brilliant. So I think we have time for one more, and this is this is from Circuits Wizard, and I'm assuming Circuits is the first name, Wizard second name. Wizard is a very popular surname, as we know, here in the Midwestern United States. But this is actually a student, an engineering student at the University of Iowa, and is asking, should I complete my degree in engineering at the university and also use edX platform, or should I? It sounds like what she's basically asking is, should I complete my degree here, or is it time for me to switch over and do it completely online?
I think if you are already partway through a degree, our society employment is such that the degree is still important. 10, 20, 30 years from now, I don't know where the world will be and whether micro-credentials will suffice. But for now, a degree is important. So you should definitely continue with the degree. But at the same time, you want to beef up your resume. You want to beef up the skills that you know. And so even as you're in college, I encourage you to take and earn micro-credentials, which will make your resume stronger. And depending on your field, learn about tiny machine learning from Harvard, learn about, and Google, learn about project management from RIT, or learn about data science from MIT. And you can earn these credentials even as you're graduating, so that in your resume or LinkedIn profile, you can have a bachelor's from your university. And then you can also list, hey, I have a MicroMasters from MIT, or a MicroMasters from Georgia Tech. And these will help you beef up your resume and also give you the skills that you need to excel in your job. So you can start your job on day one and hit the ground running.
That's excellent guidance. And I don't think Circuits Wizard was asking for my opinion, but my opinion is I would absolutely second what Anant you've just said is you're into it now. Finish it, complete it. You'll find there are tremendous benefits to the education that you are currently receiving, but you have a free platform to engage with that will give you the very specific education and round out your education in that way with edX. So take advantage of both. I think it's not a binary, thing. Make it a hybrid model, and I think everybody wins then.
Totally agree.
Yeah. Well, Anant, this, my gosh, what a joy it is to speak with someone so committed to improving the world through education and doing very real things that we can all take advantage of right now. This has been a real treat. And for those of you who are watching this at home or at work, remember, this is your week to take advantage of 50 live sessions with the leaders in our industry. And, we start at 9 a.m. Eastern every day for Industry Tech Days. through September 4th, and you can join us live or on demand for all sessions throughout the week at allaboutcircuits.com. Anant, thank you so much for your time. This has been incredibly illuminating. And like I said, this is yet again another instance where I want to completely divert my career and start getting involved in this.
Well, Dave, it was an absolute blast chatting with you because this discussion was at the intersection of two topics near and dear to my heart, circuits and the future of education. So it's been absolutely a blast. Thank you for having me.
Absolutely. We'll do this again. Thank you.
Absolutely. Thank you. Thank you so much.
Okay, everybody. Take care. We'll see you tomorrow.
Bye-bye.
That was Anant Agarwal, founder and CEO of edX, and that was a conversation that we recorded on September 1st, 2020, as a keynote address for Industry Tech Days. In our next episode, we'll talk all about open source technology and artificial intelligence through the context of high-stakes auto racing. My guest will be Formula E driver Lucas DeGrassi and RoboRace's Bryn Belcom. Don't miss it. It's going to be awesome. Thanks for listening.